you ever had this box of candies and not felt like throwing it away once you finish all the candies? Well, today you're in luck, because in the spirit of environmental awareness, I am going to show you how to turn this box of candies into a cell phone charger. Stay tuned. For this project, you're going to need a box of candies, 2 identical lithium batteries, a DC to DC boost converter, a lithium battery charging module, an LED, 2-way switch, and some DC power cord. And as for the tools, you're going to need a power drill, a soldering iron, solder wire, solder paste, a multi-purpose helping hand, a precision knife, a multimeter, epoxies, wire stripper, and breadboard. Here is the schematic of the cell phone charger. So first, you're going to have a TP 4056. This is a lithium polymer charging module, and it is going to draw a DC signal of 5 volt from the AC power outlet. Actually, it doesn't draw 5 volt directly from the power outlet, but the AC current is going to be converted into DC with this charging adapter. And from the positive output terminal, the signal is going to go positive terminal of the lithium battery, and the signal from the negative output terminal of the charging module is going to be connected to the negative terminal of the battery. And from the positive output terminal of the charging module, I'm going to connect it to a switch. When you close the switch, some current going to flow through this branch to power this LED. Here is going to be 2 resistors to act as a voltage divider to decrease the supply voltage of 3 volt, which is going to flow in actually 3.7 volt. These 2 resistors going to decrease the supply voltage to about 2.6 volt. So 2.6 volt is going to flow through this LED. Why 2.6? Because I think the brightness of LED is best when the voltage drop across it is 2.6. If it's 3.7, it's going to be too bright. And here's a DC to DC boost converter. The input signal to this boost converter is going to be again 3.7 volt, because these 2 components are in parallel and the supply voltage is 3.7. This boost converter is going to convert 3.7 to 5 volt, and that's the voltage you use to charge your cell phone battery. This is going to be grounded just to get you to see a clear picture. This is where the charging module is going to be. This is where the battery is going to be. The switch is going to be there. The LED, and here's where the boost converter is going to be. Well, this box of candy is probably made of tin or aluminum, both of which are electrically conductive. So what I'm going to do is I'm going to try to insulate the interior with this tape. Now I'm going to do the same thing to the exterior of the box to protect it from any possible scratches. Now that the interior is insulated and the outside is reasonably protected, I'm going to go ahead and make cutouts for the USB phone connector, the USB charging port, switch, and the LED status indicator. Now that we are done with the cutouts, it's time to strip off the insulator. Now I'm going to apply some solder to these two terminals of the charging module. Okay, and the next thing I'm going to do is to connect these two batteries in parallel configuration by connecting the positive terminal to the positive terminal and the negative terminal from one battery to the negative terminal of the other. You are not increasing the voltage of these two batteries. The sum of the voltage is still going to be 3.7, but you essentially increase the capacity. So that number's right there, 650 milliamp hour, is going to double. So the total capacity will be about 1300 milliamp hour. Okay, looks like it's charging. Let's wait for a while, come back to see when it's fully charged. Now you can see that the LED lamp has turned green. That means the two batteries are fully charged. Now we are going to test the components for our voltage dividing circuit. Let's measure the resistance of each resistor. This is going to be my R1 46.1. This is going to be my R2. Measure at 98.5, and that's the LED. I actually have a bigger LED too, but since the space is very limited in the candy box, I think I'm gonna go with the smaller LED. Let's set up the circuit for voltage divider. The R1 is going in here, and my R2. Let's send some voltage into my circuit. I'm going to turn on my bench power supply of 4 volt. I'm going to just measure it for you so you can see that the incoming voltage is 4. So it's about 3.9. That's good enough. Okay, let's measure the voltage drop. Should be about 2.7 volt. Here it is, 2.6, not too bad. Okay, now let's measure the voltage drop across the second resistor. Should be about 2.6. Here it is, 2.6. If you wonder how I came up with these two values, please check out my video about voltage divider circuit. Now let's put LED in our circuit. The longer legs is anode and this is cathode. You can also look at some metal plate inside. The smaller one is anode and the bigger one is cathode. The anode will be connected to the positive terminal of the battery, and the cathode will be connected to the negative terminal of the battery. So I go this way. Cool. Okay. So the LED lights up. Let's measure the LED voltage. It is about 3.0. Alright, so I think I have tasted every key component, and I think it's time that I put everything together to make a one functioning cell phone charger.
I went across to Switzerland where all the yodelers be to try to learn to yodel with my yodel-o-dee. I climbed a big high mountain on a clear and sunny day and met a yodeling gal up in a little Swiss chalet. She taught me to yodel, yodel-o-dee, yodel-o-dee, yodel-o-dee. She taught me to yodel, yodel-o-dee, yodel-o-dee, yodel-o-dee. Ho-lo-dee-lo-dee-lo-dee-lo-dee, ho-lo-dee-lo-dee-lo-dee-lo-dee-lo-dee, ho-lo-dee-lo-dee-lo-dee-lo-dee, ho-lo-dee-lo-dee-lo-dee-lo-dee. Well, now I'm gonna teach you how to yodel just like me. It's easy when you're singing to go yodel-o-dee. First you take a deep breath and it's KO 1, 2, 3. Then you'll hear yodel if you listen close to me. Yeah, this is how to yodel. Yodel-o-dee, yodel-o-dee, yodel-o-dee. This is how to yodel. Yodel-o-dee, yodel-o-dee, yodel-o-dee.
So I'm encountering a problem I did not expect. It turns out that the USB connector is being blocked by some part of the top cover of the lid. So that means more grinding needs to be done. And after the grinding, the USB connector can be plugged into the USB port with no problem.
here comes the moment of truth. And it works.